everyone, welcome to the control system lecture. Today's our topic is introduction to control system. So first of all, what is input, output and the system? So here the block diagram of the system is given. So input is the stimulus or the excitation applied to a system. Output is the actual response obtained from a system, and a system is an arrangement of or a combination of a different physical components connected. So that means to regulate, direct or command a system so that we can get the desired objective output. Now what is the control system? Combination of system plus control, it's become the control system. So the next one is the definition of the control system. It is an arrangement of different physical elements connected in such a manner so as to regulate, direct or command itself to achieve a certain objective. So there next is the difference between the system and the control system. Using the system, whatever input is given, we can get the proper output. It may or may not be desirable, and using the control system we can get the proper desirable output. Now let's take one example to differentiate between the system and the control system. So a fan with the input 230 volt 50 Hz AC supply and the output is the airflow. Now the first criteria is a fan without blade cannot be a system because it cannot provide a desired proper output, that means the airflow. So input is given, we cannot get the output. Now the next modification is that a fan with blade but without a regulator, it can be a system because it can provide a proper output, that means it is airflow, but it cannot be a control system because it cannot be a provide a desired output, that means a control airflow. Now the next modification is a fan with a blades and with a regulator can be a control system because it can provide a desired output, that means a control airflow. Here you can see that a input is given, a control element, we can put here regulator so that we can get the control airflow. Okay, now the classification of the control system depending upon the control action, they are classified into two types. First one is the open loop system and the second one is the closed loop control system. So first of all, open loop system in which the control action is totally independent of the output of the system. So here the block diagram of the open loop control system. Reference input is given to the controller. After the process we can get the control output. This is the example of the open loop system. We can take camera as the input. In the process we can put here computer, and as the output we can put here printer. So whatever input is given, computer is processing and we can get the hard copy of the photo. Okay, so this is the example of the open loop control system. Now the other example is electrical hand dryer, automatic washing machine, bread toaster and the automatic tea coffee vending machine. Now the next is advantages of open loop control system. So it is simple in construction and design, it is economical, it is easy to maintain, generally the output is stable and it is convenient to use as output is difficult to measure. Now the disadvantages is they are inaccurate, they are unreliable, any change in output cannot be corrected automatically. Okay, so to overcome the disadvantages, the next system is the closed loop system. A system in which the control action is somehow depend on the output is called a closed loop system. So this is the block diagram of the closed loop system. In the closed loop system, we have used two paths. First one is the forward path and the second one is the feedback path. So command input is given to the reference transducer. After that, we have put a summing point. What is the summing point? Where two or more input signal is connected. After the summing point, a controller is connected. After the controller, a plant is there and we can get the control output. Now the output signal is given to the feedback transducer and the feedback signal is connected to the summing point. So whenever the error is generated, error signal is add or subtract with the summing point and we can get the proper desirable output. So this is the example of the closed loop system. Here a computer controller is connected. After that we can connect a process and we have used here a speed sensor as a feedback element. Okay, so the next is the automatic electric iron. Here also a input is given and our output is the actual dryness of the cloth. For that we can use here temperature sensor as the feedback element. So temperature sensor senses the temperature of the iron and for that we can adjust the temperature and for that we can get the actual dry cloth as a output device. Now the advantages of the closed loop control system are more accurate even in the presence of non-linearity, highly accurate as any error is corrected due to the presence of the feedback signal. The bandwidth range is large compared to the open loop control system. The sensitivity of the system may be made small to make the system more stable and the system is less affected by the noise. Okay, what is the disadvantages? They are costlier, they can complicated to design, require more maintenance, feedback leads to oscillatory response, overall gain is reduced due to the presence of the feedback. And the stability is the major problem and more care is needed to design a stable closed loop system. Okay, now the comparison of the open loop and the closed loop. So in the open loop system there is a no feedback and the closed loop system feedback exists. In the open loop system no error detected and in the closed loop system error detected is present. In the open loop they are inaccurate, closed loop is accurate. Open loop is highly sensitive to parameter changes and the closed loop is less sensitive to parameter changes. The bandwidth of the open loop system is small and the closed loop system is large. Open loop system output is generally stable and in the closed loop it may become unstable. Open loop system is economically and the closed loop system is costly. And the example of the open loop system is coffee maker and hair dryer and the example of the closed loop system is guided missile servo voltage stabilizer. Next classification is linear control system and non-linear control system. So in the linear system it must obey the law of superposition and the stability of the linear system depends on the root location. So it do not exhibit the hysteresis and the jump response. In the non-linear system it do not obey the law of superposition. So the stability of the non-linear system depends on the root location as well as the initial condition and the types of input. We have generally 4 types of input: step input, ramp input, parabolic input and the impulse input. And the non-linear system exhibits the self-sustained oscillation of fixed frequency. Now the difference between linear and the non-linear. Linear system obey the superposition. Non-linear system do not obey the superposition. Linear system can be analyzed by the standard test signal and non-linear system cannot be analyzed by standard test signal. Stability in the linear system depends on the root location, and the non-linear system stability depends on the root location as well as the initial condition and the types of input. Linear system do not exhibit the limit cycle, and the non-linear system exhibits the limit cycle. Next is linear system do not exhibit the hysteresis and the jump response. Non-linear system exhibits the hysteresis and the jump response. And the last difference is linear system can be analyzed by the Laplace and the Z transform. Non-linear system cannot be analyzed by Laplace and the Z transform. Now the next classification is time varying control system and the time invariant control system. So the system whose parameters vary with time are called time varying control system, and when the parameters do not vary with time, it is called a time invariant control system. Okay, so the mass of the missile or rocket reduced as fuel is burnt, and the parameter of mass is time varying, and the control system is time varying control system. And the last one is the classification of the control system. First one is the natural control system. It is depend upon the nature. The next one is the man-made control system. The third one is the combination of the control system, that means natural plus man-made control system. The fourth one is the time variant and time invariant control system. It is depend on time and does not depend on time. The next one is the linear, that means the obey the superposition, and non-linear, that means it do not obey the superposition law. The next one is the continuous time system and the discrete time system. Next one is the lump and the distributed. In the lump, we have generally used the normal electrical parameter like resistor, inductor and capacitor, and the distributed control system we have used a very different differential equation. Next is the SISO and MIMO. SISO, that means single input single output, and the MIMO, that means multi input multi output. And the last one is the open loop and the closed loop control system. Thank you everyone.